Hello students, in the last lecture I completed the 8086 microprocessor architecture. In this lecture I will be starting 8086 pin configuration. So as I've told you when I was discussing the features of 8086 microprocessor, I told you that there are two modes of operation for Intel 8086 microprocessor. That is the minimum mode and the maximum mode. So when only one 8086 microprocessor is to be used in a microcomputer system, the 8086 is used in the minimum mode of operation. In this mode, the CPU, that is the microprocessor, issues the control signals required by memory and input-output devices. In a multiprocessor system, it operates in the maximum mode. In case of maximum mode of operation, control signals are issued by Intel 8288 bus controller, which is used with the 8086 microprocessor for this very purpose. So the level of the pin, that is Mn by Mx bar, the level of the pin decides whether the microprocessor will work in minimum mode or maximum mode. So this, if M by Mx bar is high, when Mn by Mx bar pin is high, the CPU operates in the minimum mode, and when it is low, the CPU operates in the maximum mode. So for minimum mode we have different set of pins, for maximum mode we have different set of pins, and we have common pins for both the minimum and the maximum mode. So first I'm going to discuss about the common pins that are common to both minimum and maximum mode. Then we'll go for minimum mode extra pins, and then we'll go for maximum mode extra pins. So these are the common pins that are available in both the modes, that is minimum mode and maximum mode. So as I've told you that the common pins, among all the common pins, as 8086 microprocessor is a 40 pin IC. So among those pins, these are the common pins, and among the common pins, that the first pin that I am going to discuss is reset. So this reset pin, what it does, it clears the program status word, instruction pointer, data segment register, stack segment register, extra segment register, and the instruction queue. It clears these things. It then sets code segment register to F, 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 FH. This signal must be high for at least 4 clock cycles. So when reset is removed, 8086 will fetch its next instruction from physical address FFFF0H. Why? Because when reset pin is high, it makes the code segment register content to FFFF, and after the removal of the reset pin, when the reset status is removed, when it gets low, so what will happen, 8086 will fetch its next instruction from the code segment having this address, having the starting address FFF0. So the next pin is ready pin. If this pin is slow, the 8086 microprocessor enters into the wait state. If this signal is used, basically this signal is used primarily to synchronize slower peripherals with the microprocessor. Or you can say the addressed input, output, or memory sends acknowledgement through this pin. When high, it indicates that the peripheral is ready to transfer data. If this signal is low, the 8086 enters into wait state, and basically to synchronize the slower peripherals with the microprocessor, this pin is used. The next pin is TEST bar, test bar. So this signal is only used by the wait instruction. The 8086 microprocessor enters into a wait state after execution of the wait instruction until a low signal on the test bar pin. Next pin is RD bar. So RD bar is low whenever the 8086 microprocessor is reading data from memory or an input output device. Then I've already discussed about MN/MX bar pin. I've already discussed about this pin, that the 8086 can be configured in either minimum mode or maximum mode using this pin. This pin is tied high for minimum mode. Now the next pins are, these are the ground, clock pins and VCC pin. So we have VCC pin at pin number 40, we have ground pin at 1 and 20, and we have clock at 19. So the clock, I've already discussed in the features of 8086 microprocessor that it provides the basic timing for the microprocessor and bus controller. It is asymmetric with 33% duty cycle to provide optimized internal timing. And VCC pin, that is pin number 40, basically plus 5 volt power supply pin is used here. The next pins are address or data lines pins, that is AD0 to AD15 from pin 2 to 16 and 39. It acts as address bus during the, means these pins, this multiplexed address data line pins acts as address bus during the first part of machine cycle and data bus for the remaining part of the machine cycle. The next pin is A16 to A19, or you can say that is A16/S3, A17/S4, A18/S5 and A19/S6. So these are the pins A16, A17, A18, A19 with /S3, S4, S5 and S6. So during the first part of machine cycle, these are used to output upper 4 bits of address. Means these work as A16 to A19 pins for the first part of the machine cycle. During remaining part of the machine cycle, these are used to output status which indicates the type of operation to be performed in that machine cycle. So S3 and S4 indicates the segment register being used in that machine cycle. So if S3 and S4 both are 00 means the register that is being used is extra segment register. If S4 is 0 and S3 is 1 means stack segment register is being used. If S3 and S4 they are having statuses 0, 1, then code segment register is being used, and if both are 1 means data segment register is being used. And S5, as you can see, the S5 it gives the current setting of the interrupt flag. S6 is always 0. Basically it's always logically 0, that indicating 8086 microprocessor is having the control of the bus. If S6 is tri-stated means another bus master has taken control of the system bus. I'll discuss about S7 in my next slide later. So the next pin is NMI, that is non-maskable interrupt. Basically it is a non-maskable interrupt. It cannot be disabled or masked by user by using software. It is used by the processor to handle emergency conditions. For example, it can be used to save program and data in case of power failure. An external electronic circuitry is used to detect power failure and to send an interrupt signal to 8086 microprocessor through this NMI, that is non-maskable interrupt line. Next pin is INTR. INTR, it is a maskable interrupt. It is a maskable interrupt. It can be enabled or disabled using interrupt flag. After receiving INTR interrupt from an external device, the 8086 acknowledges through INTA bar signal. It is sampled during the last clock cycle of each instruction to determine if the processor should enter into an interrupt service routine or not. So I'm ending this class here. We'll continue with the same pin configuration of 8086 microprocessor. One more pin is remaining in the common pins of minimum mode and maximum mode of 8086 microprocessor. One more pin is remaining, that is BHE bar slash S7. I hope all the pins I've covered. So after covering BHE bar by S7 pin, we'll move towards the pins for minimum mode, and then I'll discuss about the pins for maximum mode. So I'm ending this class here. Thank you.